looking at this table, how are we going to know if it's odd or even or neither?
Because they're both pointing up at the end. They're both
Okay, looking at in behavior. Uh-huh.
The input and output values.
Okay, the input and output values. So there's a chance that they could like both be pointing up, but it not be like perfect, an even function. I probably wasn't specific enough in my question. So we talked about odd degree, even degree just a minute ago for polynomials. Even more specific than that, an even function has symmetry about the y-axis. Oh, come on. So, for example, a lot of you figured out this one does have symmetry about the y-axis. Both ends do point up. So this is just a random example. I know it's not perfectly symmetrical the way I drew it. But here's the real reason that something is an even function. If you calculate f of negative x, so if you take its input and you give it the opposite signed input, you get the same thing as if you plug in the positive version of that x value. Okay, what? So, for example, if I pick a negative out here, I don't know, let's say it's -2, and I see where the graph is, when I go to +2, if I've drawn my graph right, it's going to give me close to the same, it should be the exact same y value. So it's saying -x and +x give me the same output value. You can also use this, you did it in Algebra 2, but I know that's even longer ago. We would plug a -x into an equation in standard form, and we'd check and see, did all the signs change? Did all the signs stay the same? And to decide if it's even or odd. If something is an odd function, not just odd degree, but to be an odd function, it has symmetry about the origin. So, like, if you see this as 1/2 of the graph, it has rotational symmetry. And then the opposite, or I guess, now I need to brush up on my geometry. The converse is true. I don't know. F of -x equals negative f of x. So what that means is when we pick x values with opposite signs, their outputs are going to be the opposite sign. So in order for you to answer this question, I had to give you some inputs that had opposite signs from each other, and you had to see how their outputs compared. Right? So yes, even was correct that y'all said. I just wanted to make sure that we had the reasoning behind it. So we could say g of x is an even function. And if it asked why, how do we know? We could say g of -x equals g of x. So that means g of -3 and g of +3 were the same. G of -1 and +1 were the same. Yes?
So it doesn't have to be an even function if it's raised to an even power?
Right. So it could be like an even power, but if we shift it away from the y-axis, then it doesn't have this property of an even function. So it's like a more exclusive group of even degree.
Okay.
Are you going to see it come up? Is it going to come up a lot? No, but we studied it in the fall, in the first 9 weeks. It's just been a minute.
Oh, wait, so if it's like, let's say it has a power of 4, right? So that's even, but
Degree.
Yeah, but it's not, it couldn't be an even function if
Correct.
it was shifted, because you have to still plug in values to see if it's okay.
Yeah. Hey, y'all, going back to the example we did earlier, we said that this graph was an even function for sure, based on its shape, its in behavior, its degree. We knew it was degree 4, but that doesn't mean it's an even function with even symmetry. I don't know if I just said the wrong thing. It's even degree, not an even function. End of statement.
Can I have an eraser?
An eraser, yes. Okay. Yes. It does. So the one that we had earlier was just even degree, but doesn't have the special symmetry.
So you can't call it.
We can't call it an even function, but we can say it's even degree. Its highest exponent is even, but that's all I can say. Okay, y'all, did you determine that this was linear, quadratic, or exponential?
Quadratic.
Okay, great. What about, did you get specific with it? Like, did you just kind of look and say, oh, yeah, I can tell? Okay. Well, we're going to go over all of the justifications for these statements as we review. But do you remember we would have to check for consecutive, equal length input value intervals? Right? So they're all in a row, they're the same distance apart from each other, and then we would have to see how that function is changing over those consecutive equal length input value intervals. Yeah, we'll practice. Minus 16, minus 8, plus 0. Now we're plus 8, plus 16, plus something else. Right, 23. Okay. Yes. Oh, sorry.
Am I allowed to have a function
Or under the fraction? Yes, you got it. Okay, so looking at this, as we, oh wait, 23? Was that 23? Oh man, I think I made a mistake when I made this function. So let's just not analyze this one little number right here. I was gonna say, wait, this is not this is not working. All right, that's fine. Not a 42 there. Let's see. I think it needed to be, what was I doing? Squared minus 5. 49 minus 5 is only 44. Okay, well, that's fine. Okay, so looking at this, we could say that this is quadratic for a couple of reasons. It's not a constant rate of change, but what do we notice in the rate of change? If I actually were going to divide them throughout the table, negative 16 divided by 2 is negative 8. Negative 8 divided by 2 is negative 4. 0, 4, 8. Okay, almost done. So this rate of change is changing at a constant rate. So we could say that the rate of change is increasing at a constant rate. Or you could say it's increasing linearly, like it's increasing in a linear pattern. All right, and then almost done. If we know the average rate of change, or the rate of change in these equal length input value intervals, if we know it's increasing, then what does that tell us about the concavity? Yes, g of x is concave up. And we just listed the reason. The rate of change is increasing. I did. I divided those by 2. Yep, good call. Oh, because that was the change in my x, right? The change in my input. Okay, and then last 2 questions. I know I just now changed the value once I realized my whoops. So g of negative 7 we said would probably be positive 44 since it's an even function. Since I made a whoops on my rate of change. And y'all, you just had to do this on the last test. Your average rate of change we're going to be expected to show our work. We know the formula is f of b minus f of a over b minus a. Oops. But here, function names are going to be important. So this is not f of x. Yeah, this is g of 5 minus g of negative 3 over 5 minus negative 3. And then thankfully we don't have to do any real work to find those values. They're in the table. G of 5 is 19. G of negative 3 is 3. Divided by 5 plus 3. Right, so 16 over 8 is 2. Yay!